Today we're talking about verifying more equations that are identities. And these ones are a little bit more complicated, but again, it goes back to, do you know the Pythagorean identities? Do you know your reciprocal identities? Do you know your quotient identities? And in particular, I started with Pythagorean identities because as I look at this problem of 1 plus tangent squared x divided by cosecant of x times secant of x, my question is, do we have an identity that goes with our numerator, the top of the fraction, 1 plus tangent squared of x? And if we take out our yellow sheets, if we haven't already, and we look at that, I know it's written as 1 plus tangent squared x in the problem, but if you look at your yellow sheet, it says tangent squared theta plus 1 equals secant squared theta. So instead of writing 1 plus tangent squared, we can fill in what tangent squared equals, which is going to be secant squared x in this case. If you prefer to write theta. And in our denominator, we still have cosecant of x and secant of x. We're only going to work on one side of the equation. In this case, again, the left-hand side, which is often the more complicated side. But also keep in mind here that the more complicated side could be on the right side. But as we take a look at this one here, if we simplify this a little bit more, secant squared means secant x times secant x divided by cosecant of x times secant of x. And the question then becomes is, do we have anything exactly the same on the top and on the bottom? Well, what we have is we've got a secant x, and we can cancel that out. Secant x divided by secant x is 1, and we're left with secant x divided by cosecant of x. One of our other tips for starting trig verifications is to try to rewrite everything in terms of sine and cosine. And again, we're still trying to turn the left side of the equation into the right side. But one thing, well, let's just convert. Secant x is the same thing as 1 divided by cosine of x. And cosecant of x is the same thing as 1 divided by sine of x. Those are the reciprocal identities. But oftentimes when it's written like this, it's kind of confusing to people, and that's why I like to go old school, as I call it. Why not write it as 1 divided by cosine x divided by 1 divided by sine of x? And when we divide it, when dividing, don't ask why. Flip the second one and multiply. So this becomes 1 over cosine of x times sine of x over 1. And when we multiply here, I'm going to draw an arrow, I'm going to put it back under here. But when we multiply, we're going to multiply the tops of the fraction together, and we're going to multiply the bottoms of the fractions. So we get sine of x, times sine of x. Cosine of x times 1 is cosine of x. And again, we're still trying to turn this left side of our equation into the right side of the equation. But finally, if we know the definition of tangent, tangent is sine x divided by cosine x. And there, we verify. If we take a look at problem number 2, I want to go back to our yellow paper and look at one particular idea on the tips for starting the trig verifications. And it's about halfway down the paper, and what it says is, it says, if the expression is 1 plus or minus sine or cosine, not squared, and part of a fraction, multiply the fraction by a fancy form of 1. That is the conjugate. We change one sign in the expression. We're going to multiply that by the conjugate, the top and the bottom, and then we might make some form of a Pythagorean identity. So I say that here Because in this particular case, the more complicated side is the left side of this equation. And then what we're going to do is we're going to try that. We've got cosecant theta plus cotangent of theta. Let's multiply the bottom of this fraction by cosecant theta minus cotangent of theta. But if we multiply the bottom of the fraction by that value, we have to multiply the top of the fraction by that as well. And that's what I sometimes refer to as the fancy form of 1. When we multiply the top of the fraction, it's 1 times this. So we're going to get cosecant theta minus cotangent of theta. But down here in the bottom, we're going to have to double distribute or to FOIL. When we multiply this, we get cosecant of theta times cosecant of theta, which is cosecant squared of theta. Cosecant of theta times cotangent of theta, which is cosecant theta cotangent theta. Positive cotangent theta times cosecant theta is positive cotangent theta cosecant theta. And then I'm running out of space here, but positive cotangent theta times negative cotangent theta is going to be minus cotangent squared of theta. First, outer, inner, last if you're doing the FOIL, double distributive otherwise. As we take a look at what we just did with the multiplication here, this term and this term that I just underlined are opposites. I know that it says cosecant cotangent, and then it says cotangent cosecant, but we can change the order without changing that value there when they're multiplied together. One of those terms is negative, one of them is positive. So we can simplify this expression a little bit more. And what we have left is we have cosecant of theta minus cotangent of theta divided by cosecant squared theta minus cotangent squared theta. So we're here, and what I'm looking for now, because we do have squares in the problem, so we might be able to use a Pythagorean identity. If we look back at our yellow paper, do we have any identity that talks about what cosecant squared theta minus cotangent squared theta equals? Looking on our paper, cosecant squared theta minus cotangent squared theta actually equals 1. So this is cosecant of theta minus cotangent of theta, all divided by 1. And we don't even really need to write the 1, but I do want to show my work there. I don't want to skip any steps. But cosecant of theta minus cotangent of theta then is what that simplifies to be. And I haven't been paying attention to the other side, but if we go back and we look at the original problem here, luckily what I see is that we have cosecant of theta minus cotangent of theta. And there, this time, for the first time I think, we have verified that the right side of the equation is the same as the left side of the equation. Cosecant of x minus cotangent of x equals sine of x divided by 1 plus cosine of x. Now that we've seen that skill with the fancy form of 1 in a problem, let's try to use it again. So we have sine of x divided by 1 plus cosine of x over here on the right side. So again, oftentimes the complicated side's on the left. So once again, in this problem, it's on the right. But what might be helpful, and I think you can maybe fit it in on your paper, is if you multiply right here in the problem by the fancy form of 1. 1 minus cosine of x, 1 minus cosine of x. I do want to point out again that we want to use the conjugate, which means that we change one sign in the binomial. In the original problem, it was 1 plus cosine x. So we're changing that sign, 1 minus cosine of x, when we do the fancy form of 1. So what we have left up here when we start that multiplication process is we have sine of x times 1 minus cosine of x. And I'm probably showing an extra step here. But then it's 1 plus cosine of x times 1 minus cosine of x. And what I'm going to recommend to you is to not multiply the top of the fraction together here until we get to a different point in the problem, because we may or may not need to. But what I do want to do is try to see what we can get in our denominator by multiplying by the conjugate, see if we can come up with a Pythagorean identity that can maybe help us with our problem. So I'm going to leave the numerator, the top of the fraction alone, and we get sine of x times 1 minus cosine of x. And then down here in the denominator, we're going to FOIL or double distribute. We get 1 minus the cosine of x plus the cosine of x minus, because positive cosine x times negative cosine x is negative cosine squared of x. And maybe you even see a pattern when we multiply by the conjugate. Because what happens here is that we've got a minus cosine x and a positive cosine x. They're like terms, and they're also opposites of each other. We simplify that, then we still have in our numerator sine of x times 1 minus cosine of x. Down here in our denominator, we have 1 minus cosine squared of x. And as we look at our yellow papers, 1 minus cosine squared of x, do we have a Pythagorean identity that's going to help us with? And we do. 1 minus cosine squared of x is sine squared of x. So if we know our Pythagorean identities, these are better. If we rewrite this a little bit better, I find that for many people it's pretty helpful. Sine x times 1 minus cosine x. We still haven't done anything to the numerator. And remember that squared means times itself. So it's sine x times sine x. And what we can ask ourselves then is, do we have anything exactly the same on the top and on the bottom? Well, we've got a sine x. And now we get 1 minus cosine x divided by sine x. But we're trying to turn this problem into cosecant x minus cotangent of x. If I pull that back up here, we're trying to turn this into cosecant of x minus cotangent of x. So we're not quite there yet. We've made good progress. But what can happen here to finish, because we're still working on the right side, is we can split this up. We can split this up, split the right side of this up into 1 divided by sine x minus cosine x divided by sine x. And we're allowed to do that because there's one term in the denominator. Just sine. That's one term. So we haven't changed anything. If we have a common denominator, we could write it as 1, which is the step above. But then, to finish, can we convert 1 over sine of x? Reciprocal gives us the cosecant of x. And what about cosine divided by sine? A quotient, which is cotangent. And sure enough, now, cosecant of x times cotangent of x.